Hello, welcome. Let's look at this number one question for chemistry for WAEC 2018. Which of the following raw materials is used in the plastic industry? Option A, ethene, B, methane, C, sulfur, D, hydrogen. So what is the answer? The answer is ethane. Why? Because when you check your textbook for the uses of ethane, you will find out that one of the uses is as a raw material for plastic industry or industries. So we can actually use methane as a raw material for plastic industry because it is an unsaturated hydrocarbon. Another very important use of ethane is that it is used
I don't see the message for thing.
To hasten. If you want to hasten the ripening of fruits, if you want your mango or your orange to ripe faster, you can use ethane for that. So ethane can be used to hasten the ripening of fruits. So ethane can be used to hasten the ripening of fruits in agriculture. So that is one of the agricultural uses of ethane. So note that ethane, for this very use, the ethane has to be in low concentration. It has to be in low concentration for it to be used in this way. So you can actually find this very topic in organic chemistry. So if you check organic chemistry under ethene or under alkanes, ethene is one of the alkanes. So if you check alkanes and check uses of ethene, you're going to see this as one of the uses. So take note. Please make sure you hit the subscribe button at the side of the screen so that you can always get our questions. Please, if you have any challenges, please drop it on the comment section. As I said before, which of the following raw materials is used in the plastic industry? Option A, ethene, B, methane, C, sulfur, D, hydrogen. The answer is ethene because unsaturated hydrocarbons, that is hydrocarbons with double bonds, are normally used for such reasons. If you check your textbook under the uses of ethene, you're going to be able to see that it is used as raw material for plastic industry. Hello, let's look at the number 2 question. Which of the following organic compounds can undergo both addition and substitution reaction? Option A, pentane, B, benzene, C, propane, D, hexane. The answer is B, benzene. Why is B, benzene, the answer? Because the chemical property of benzene is that it undergoes substitution reaction as well as addition reaction. So when you check the textbook for the chemical properties of benzene, you will be able to see that the two properties that it has is, number one, substitution reaction, And number 2 is addition reaction. In substitution reaction, actually, benzene reacts with chlorine. Can have benzene reacting with chlorine to form chlorobenzene. So that is a substitution reaction. Whereas for the addition reaction, you can have mixtures of benzene vapor and hydrogen passed over nickel catalyst at 180 degrees. So when you have mixture of benzene vapor and hydrogen passed over nickel catalyst, it has to be over nickel catalyst and a temperature of 180 degrees, you can have what we call addition reaction, and this gives a chemical known as cyclohexane.
If that's in a
So
video
check
we
your
do every morning.
textbook under
It's what it means.
organic chemistry, specifically under
Your phone is ringing.
benzene. Check
Na
chemical
Preferential
properties of benzene. You see that
Okay.
simple that we
these
don't
two
get this
reactions are the types of reactions that benzene
one or two
take part in.
Wait, they phone you.
So the answer is benzene.
Wait,
So
is
why
that for
is
back?
it possible for benzene to undergo such reactions?
You get anybody with part like that?
Because
very quiet.
very important.
Okay.
It
Wait,
is
that the way we dey produce
unsaturated.
really thought say she hate boys wait something.
Benzene is an unsaturated
Yeah.
hydrocarbon.
But she thought small now.
Yeah.
She won't look more mature than many of those girls.
So you have to take note of this.
I hope say our guy go the web
Only
also.
that say now only we begin at 37.
I'm telling you, you observe
All
plan.
of us we dey the same thing we are beginners.
You guys say they come potentially purpose for one place.
Yes, let's look at
Why?
question number 3. Which
Why?
of the
Like some
following
people
equations
they do
represents
lobbying
a
for this.
redox reaction?
But they lobby
Which
for
of the following equations represents a
our staff
redox
now.
Only I
reaction?
don't want what I know is that
Answer
the
Our
time
phone,
going on
all of us will be
I'll
our
be a
phone.
good
We
So
know
we're going to find out why D is the answer to
so we say
this
we want
question.
level food like that.
Now,
But it
what
don't really
is a
mean sha. It don't really
redox
what I know
reaction?
that before in fact
Una dey the same pod.
it will even be easier
Me,
for
him, Itoyi,
easier
A
for us.
redox
So,
I
reaction.
want girl. I want girl like
What
that.
happens in a redox
at
reaction?
least
In a redox reaction,
staff
oxidation involves
associate will not
loss
be
of
maybe because of one
electrons,
person.
while reduction is a process involving gain of electrons. So, an oxidizing agent is a substance which accepts electrons, and a reducing agent is one that donates electrons. So if we check out this equation, if we check out the equation where we have 2H2S plus SO2 to give 2HO2 plus 3S. Now, we are going to check the oxidation state of sulfur in this, or oxidation state of sulfur in this, and now check what it becomes here to see whether there is reduction or addition. Now, sulfur in SO2 has the oxidation state or oxidation number of 4. So that is the oxidation number of sulfur in this. Whereas sulfur in 3s, sulfur here, has the oxidation state or oxidation number of 0. So with this you can see there is decrease from 4 here to 0 here. Because of that, we can say that there is redox reaction. Once there is change in the oxidation number of a particular element, you can say that there is a redox reaction. Hello, welcome. Let's look at this question. The process of extraction of iron from Is ore is option A, decomposition, B, oxidation, C, reduction, D, sublimation. The answer to this question is actually reduction. Now, why is it reduction? It is reduction because iron ore is reduced to iron by carbon 4 oxide or carbon 2 oxide actually, formed by the action of carbon 4 oxide on white coke in the extraction of iron from Is ore. So the answer is actually reduction, and it can be found in Iron and its Compounds chapter in your chemistry textbook. So we know that iron ore is reduced to iron by CO, which is carbon monoxide, and this CO is actually formed. This is the process of extraction of iron from Is ore. This CO is formed by the action of CO2, which is carbon 4 oxide, on white coke in the extraction of iron from its ore. So the action is actually a reduction, and this can be found in the chapter for iron and its compounds in your chemistry textbook. So when you have your furnace, so inside the furnace there are reactions going on. So when you have your CO2 reacting with white coke, you are going to get what we call CO, and it is this CO that will react with your iron oxide, reducing it. This iron oxide is actually called hematite, that will now reduce it to ordinary iron. So that's how you go about getting your iron, because of the reduction of this iron ore, removing this oxygen, to give you only iron, which is what you actually need. So this reduction of this iron ore to ordinary iron is what we call, is how we go about extracting our iron from this ore, and that's why the correct option here is reduction. So please take note of this. This is what happens in this furnace. Okay, so there is a reaction between CO2 and white coke to give CO. So this CO reduces your iron ore to ordinary iron. So that's why that is the answer. Please, if you like this, hit the subscribe button by this side of your screen. Support us in any way that you can. Thank you and God bless you. Also know that the ore for iron is hematite. Very, very important. The name of this iron ore, this very iron ore, the name is hematite. So take note. So this iron ore is reduced by CO, which is carbon monoxide, to ordinary iron. And how do you get this CO that reduces it? You get it by the action of CO2, which is carbon dioxide, on white coke to get this CO. So this CO reduces this to iron. So take note, that is what actually happens. Please hit the subscribe button. Thank you and God bless you. Welcome. Let's look at this question. What is the solubility of a salt if 0.4 gram of it is obtained on evaporation of 200 cm cubed of each saturated solution to dryness? Option A, 0.8 gram per dm cubed. B, 2.00 gram per dm cubed. C, 8.00 gram per dm cubed. D, 80.00 gram per dm cubed. Now, how do we solve this? We are given that we are going to start solving these by actually noting that we are given 200 cm cubed, and this is saturated with 0.4 gram of the salt. That is what is given here, that if 0.4 gram of it is obtained on the evaporation of 200 cm cube, meaning that 200 cm cube is actually saturated by 0.4 gram of the salt. Now, noting that, we can now say that 1000 cm cubed or 1 dm cube, which is actually what we'll take when we are talking about solubility, will be saturated by X gram. So now this very X gram that is going to give us the solubility, if you cross multiply, we are going to have that 1000, this 1000 times the 0.4 all over 200, and this will give us 2.00 gram per dm cubed. So this is the answer, and this is option B. So that's how you go about it. Why do we use 1000 here? We use 1000 because we know that the definition of solubility is actually that the solubility of a solute in a solvent at a particular temperature is the maximum amount of the solute in moles or grams that will saturate 1 dm cube. That will saturate 1 dm cube of the solvent at that temperature. So taking into cognizance of this definition of solubility, we can actually do this calculation that since we have 0.4 inside 200, what do we have inside 1000 cm cube or 1 dm cube? We actually have 2.0 grams. So actually, since we have 2.0 grams in 1 dm cube, we can say that the solubility is 2.00 gram per dm cube. Please, if you like this video, please hit the subscribe button by this side of your screen. Thank you for supporting us. God bless you. Like I said before, solubility definition is actually that the solubility of a solute in a solvent at a particular temperature is the maximum amount of the solute in moles or grams that will saturate 1 dm cube of the solvent at that temperature. So once you're given your parameters, you have to make it for 1000. So that any amount of solute that can be gotten in 1000 is actually the solubility. Hello, welcome. Let's look at this question. An acidic salt has option A, double anions in its aqueous solution, B, a single cation in its aqueous solution, C, hydrogen ions in its aqueous solution, D, hydrogen ions in its aqueous solution. Hydrogen atoms in its aqueous solution. So what is the answer? The answer to this is actually C. Hello, welcome. Let's look at this question for WAEC Chemistry, number 6 question for 2018. An acidic salt has A, double anions in its aqueous solution, B, a single cation in its aqueous solution, C, hydrogen ions in its aqueous solution, D, hydrogen atoms in its aqueous solution. The answer to this problem is C, hydrogen ions in its aqueous solution. The reason is that an acid salt or acid salts are formed when the replaceable hydrogen ions in acids are only partially replaced by a metal. They are produced only by acids containing more than one replaceable hydrogen ion. So in this case, we are having, say, H2SO4 in aqueous solution plus KOH aqueous, and this will give us KHSO4 aqueous plus H2O liquid. So this is actually what we call an acid salt. This is supposed to be KSO4, but we have KH. We still have remaining H. You can see here we have 2H. So once there is hydrogen still remaining, we'll call it acid salt. And like I said, an acid salt is from when a replaceable hydrogen, this hydrogen is supposed to be replaced totally by this K, but you can see it's only one that is replaced by K. The other one is still remaining here. So this one, because of this one still remaining, we say that this is an acid salt. So you can check the textbook for acid salts under salts. That is where you find this answer. So note that, very importantly, acid salts are formed. They are formed when the replaceable hydrogen ions in acids are only partially replaced. When they are only partially, so this is the replaceable hydrogen in the acid. So had it been there is complete replacement of this hydrogen, we'll call it, we know that we have normal salt, but it's only one that is replaced and one is still remaining here, so we'll call it acid salt. So whenever they are partially replaced by a metal, the metal replacing it in this our case is K, which is potassium. So that is whenever this happens, we have acid salt. Also, bear it in mind that they are produced only by acids containing more than one replaceable hydrogen ion. So take note, this one has more than one, it has two. So it must have more than one replaceable hydrogen ion. The acid must have, this is the acid, H2SO4 is an acid, this is the base. So whenever there is combination between an acid and a base, you're supposed to have a salt and water. But if the acid has more than one replaceable hydrogen ion that is not fully replaced by the metal, so you're still having hydrogen in the salt, we call it an acid salt. So that makes C the correct answer to this problem, that an acidic salt has hydrogen ion in the aqueous solution. This is the aqueous solution and this is the hydrogen ion. So this makes this the answer to this problem. Please, if you like this, please hit the subscribe button so that you can always, the subscribe button is around the side of your screen, so that you can always get our solved problems. Thank you. God bless you. Please, you can check in your textbook for acids, salts, and base. That is the topic where you see this. Check under acid salt. When you finish studying acids and base, when you get to salt, under salt you will see acid, salts, and types of salt. So that is where you get this definition and this note that I've given. Thank you and God bless. Welcome. Let's look at question number 7 for Chemistry WAEC 2018. A reaction is endothermic if the A. reaction vessel feels cool during the reaction, B. enthalpy change is negative, C. bond forming energies it says bond breaking energy. D, heat of formation of reactants. It says heat of formation of products. So what is the answer to this question? The answer to this question is actually A. The answer is A. And why is A the answer to this question? The answer is A because for an endodemic reaction, the reaction vessel feels cool during the reaction. So why is this the case? This is the case because an endodemic reaction is one during which heat is absorbed from the surrounding. So if there is a reaction going on and heat is absorbed from the surrounding, then that surrounding has to feel cool. And the surrounding in this case is the reaction vessel. So let's take down the notes. An endodemic, this is the definition of an endodemic reaction. An endodemic reaction is one during which heat is absorbed from the surrounding. That is what an endodemic reaction is. So let's have reaction between these big substances and these small substances. So if you are having this reaction and you are having the environment as this very vessel, this is the vessel containing this. When there is reaction going on, from the definition of endodemic reaction, it is one during which heat is absorbed from the surrounding. That means heat is going from the surrounding, which is the vessel, into the reactants, or into the reactor, or into the reaction. There's movement like this from the environment into. So if the environment or the vessel is losing heat, it means that it will become cool. And that is for endodemic reaction. Now the opposite of endodemic reaction is what we call an exothermic reaction. And it is also good you know the definition. An exothermic reaction is one during which heat is liberated or given off to the surrounding. So that is exothermic. So you can find this topic in your textbook under energy and chemical reactions, so that you can be able to actually get this definition that I've given. So for every endothermic reaction, the reaction vessel, which is part of the surrounding, feels cool. For every endothermic reaction, the reaction vessel feels cool. It has to be cool because heat is absorbed from the surrounding. So if the surrounding is losing heat, it will be getting cold for every endothermic reaction. Please, if you like this, hit the subscribe button by the right hand corner this side of the screen. Thank you, and God bless you. Hello, welcome. Let's look at this question for WAEC Chemistry past question 2018, question number 8. In which of the following compounds does hydrogen form ionic compounds? In which of the following compounds does hydrogen form ionic compounds? A. CH4, B. HCl, C. NH3, D. NaH. So what is the answer? Is it in methane as option A, or hydrogen chloride as option B, or ammonia as option C, or sodium hydride? In which of the following compounds does hydrogen form ionic compound? So what is the answer to this problem? The answer is D, sodium hydride. That is the answer. So why is sodium hydride the answer to this question? It is the answer because the alkali and alkali earth metals like sodium and calcium form ionic hydrides with hydrogen, which have high melting points and are crystalline solids that conduct electricity. So when you check hydrogen and its compound in your textbook, you'll be able to see the fact that I just mentioned. And as a way of getting that note, you can write the alkali and alkali earth metals. Example is sodium and calcium. They form ionic hydrides with hydrogen. And the properties of these hydrides is that they have high melting point. I like giving you more points whenever I'm answering a question, so that even if you have questions coming, maybe another question might ask you the properties of the hydrides formed, so that from this you learn a lot of things. So that's why I don't just give the answer, but I also give explanation on other things surrounding the answer, so that anyhow you get the question, you'll be able to answer. So that have high melting points and are crystalline solids that conduct electricity. So you might be getting a question, which of the following compounds have high melting point and conducts electricity? Then you should know it's also a hydride like sodium hydride or calcium hydride. So the answer to this, like I told you, you can get this in your textbook under hydrogen and its compounds. Under hydrogen and its compounds. So if you check under hydrogen and its compound, you check the chemical properties of hydrogen, you're going to find out that it reacts with alkali and alkali earth metals. And those metals are metals like sodium and calcium. So it reacts with them to form ionic hydrides. So this is the ionic hydride or ionic compound, as it is. You can see ionic compound. So actually it forms ionic hydrides. You can see this is the ionic hydride. So whenever this alkali metal or alkali earth metal react with hydrogen, So these ionic compounds have high melting points, and they also conduct electricity. So that is the answer to this problem. Please, if you like this, hit the subscribe button. The subscribe button is by this side of your screen. If you want to get more information on this very topic, check hydrogen and its compound in your textbook. Thank you, and God bless you. Hello, welcome. Let's look at this chemistry question for WAEC 2018, question number 9. Consider the following reaction equation. Br2 reacting with Ki, 2Ki to give 2KBr plus I2. In this very reaction, this is bromine. So when bromine reacts with this potassium iodide to form potassium bromide, and you have your iodine molecules. So what is bromine acting as? Consider the following reaction equation. Bromine is acting as A, an oxidizing agent, B, a reducing agent, C, an acid, D, a base. So what is the correct answer to this question, considering the reaction equation given? The right answer is A. Bromine is acting as an oxidizing agent. And why is this so? It is so because in this very reaction where we have your bromine reacting with the potassium iodide to give potassium bromide plus the iodine molecule. In this very reaction, we can say that it will be very easy for us to find out the oxidation number of the bromine. So we can easily find out the oxidation number of the bromine. So if we are able to determine the oxidation number of the bromine, we will be able to know whether it is increasing or decreasing. So the bromine oxidation number actually reduced from 0 to -2 in 2KBr. We also noted here that it also gained or gains electron. And you know that that very substance that has its oxidation number reduced, or that very substance that gains electrons, is an oxidizing agent. So from definition, we can say that an oxidizing agent is one that gains electron. So the one that gains electrons and is reduced is the oxidizing agent. So that very reactant that gain electron is reduced is the oxidizing agent. We can also say that it's for the oxidizing agent, its oxidation number is also reduced. So its oxidation number is also reduced. So this definition that I've just given can be found under redox reaction. If you check your textbook under redox reaction, you'll be able to see this. So take note, this is actually Br2, which is this. So this Br2 from this equation, the oxidation number of bromine here is 0, and it is reduced. The oxidation number of bromine here is -2, so there is reduction in the oxidation number. You know that for a single for a molecule on its own, the oxidation number is normally 0. Now if you calculate the oxidation number of bromine in this very compound, you find out that it's -2. So when moving from this reactant side to the product side, you see a reduction between the oxidation of 0 to -2. So once a reactant is having its oxidation number reduced, you say that that reactant is an oxidizing agent, and that's why we say that bromine is an oxidizing agent here, because the oxidation number is reduced from 0 here to this very place where it is -2. So once there is reduction in oxidation number, we say that that very reactant undergoing reduction in oxidation number is an oxidizing agent, because it gives its oxidation to the other reactant. So you check the oxidation number of the very reactant that you're talking about in the reactant side first. So if the oxidation number is reduced from what it is in the reactant side to what it is in the product side, you say that it is an oxidizing agent. So another property of an oxidizing agent is that it gains electron. That very substance that gains electron during a reaction, we call it oxidizing agent. So you can find this topic under redox reaction in your textbook. So please hit on the subscribe button, subscribe to our channel, so that you can always get information and solutions like this. Please, if you have any question, drop it on the comment section of this video. Thank you. God bless.
I like what you the time is short.
Welcome. Let's look at this question number 10 for chemistry, WAEC. An organic compound has the empirical formula CH2 if its molar mass is 42 gram per mole. What is its molecular formula? Given H to be equal to 1.0, C to be equal to 12.0. A, is it C2H4? B, C3H4? C, C3H6? D, C4H8? So what is the answer to this? Now, for you to solve a problem of this kind, you should always note that the formula here is the empirical formula given, multiply it by n, it will give you the molar mass. So that is the formula. Empirical formula multiplied by n is equal to molar mass. So in this case, checking this formula will find n. So our problem will be to find n. So The empirical formula as it's given in the question is CH2. That is what is given. We are given that if this is the empirical formula, CH2. So multiply it by N, you will now get the molar mass, and the molar mass is given as 42. So that is how you solve this. And you know that C from what is given here is 12. So we can have C, in place of C, we write 12 plus H. H from what is given here is 1. So in place of H, we can say 1 times 2 because it's 2 times, it's going to be 2. Then close the bracket, N equal to 42. So 12 plus 2 is 14. So we can say that 14N is equal to 42. So that N is equal to 42 all over 14, which will give us what? 3. So N is 3. So, and we already know that empirical formula times N is equal to molar mass. You also note that empirical formula, empirical formula
If I want to add it, how do I add it?
times
And this one
N
is definitely
is also equal to
I'm not going to add it
molecular
Where do I add
formula. So that's another way of writing it. Empirical formula times N is also equal to molecular formula. So what is the empirical formula now? The empirical formula given is CH2. You can see it here, it is given CH2. So when you multiply it by N, you will get what we are looking for, which is the molecular formula. So if you now say that N is equal to 3, so what do you get? You will now have CH2 or bracket 3 to get the molecular formula. So if you open this bracket, you have C3. This 3 will go in C3. Then here we have 3 times 2. 3 times 2, so that you can now have H6. So this is the molecular formula, C3H6, because you're multiplying this 3 here, getting it into here, so it will give you C3. Then 3 now times 2 here will give you 6. So this is the molecular formula, and this makes option C the correct answer. So option C is the correct answer for this. So please take note of this formula. Empirical formula times N is equal to molar mass. Also, empirical formula times N is equal to molecular formula. So with this, you can simply solve this and you'll be happy you did. Please click the subscribe button on this part of the screen. If you have any question, drop it on the comment section. Thank you for your support and subscription. God bless you. Hello, welcome. Let's look at this question for Chemistry WAEC 2018. Question number 11. Ethane is produced from ethanol by option A, decomposition, B, hydrolysis, C, ozonolysis, D, dehydration. So what is the answer to this very question? How is ethane produced? Is it by decomposition, dehydration, hydrolysis, or ozonolysis? Actually, the answer is D, dehydration. And why is it dehydration? Because when ethanol is dehydrated by hot concentrated tetraoxosulfate 6 acid, and this is actually the removal of one molecule of water from ethanol. That's why we call it dehydration, the removal of water. So by explanation, we can have that the answer is actually dehydration, of ethanol. That's what gives ethane. And this is done using hot concentrated tetraoxosulfate 6 acid. So when you dehydrate ethanol with hot concentrated tetraoxosulfate 6 acid, you will get ethane. And why do you call this dehydration reaction? We call it dehydration because the overall change is actually the removal. Whenever there is removal of water, you say there is dehydration. So the overall change is actually the removal of one molecule of water from ethanol. So that's why we call this dehydration reaction. Now let's write the equation that represents this reaction. We have C2 H5
It's explained that in our lesson. I just want to get this now.
So this is your ethanol.
I want to pause and see how.
So when there is dehydration of this ethanol in the presence of concentrated tetraoxosulfate 6 acid, there is the removal of water in order to now give C2H4, which is ethane. So that is how you get this. You cannot actually see this in your chemistry under ethane, production of ethane. So you can see this in your textbook under production of ethane. That's how you say this. So the answer to this question is dehydration. Ethane is produced from ethanol by what? Dehydration. And this dehydration is actually the removal of one molecule of water from the ethanol. So this is your ethanol, and you're removing this water in order to get this ethane. So when you dehydrate ethanol using concentrated hot concentrated tetraoxosulfate 6 acid, you'll be able to get ethane. That is how ethane is produced, by the dehydration of this ethanol using concentrated H2SO4. So that is that. Please, if you like this, please hit the subscribe button by this side of the screen. Thank you, and God bless you. Hello, welcome. Let's look at this question number 12 for WAEC chemistry past question. Consider the following equilibrium reaction: 2AB2 gas plus B2 gas to give 2AB3 gas. Now, the heat of reaction is minus X kilojoule per mole. The backward reaction will be favored by. So what is going to favor the backward reaction? Option A, a decrease in pressure. B, an increase in pressure. C, a decrease in temperature. D, an introduction of a positive catalyst. So what is going to favor the backward reaction? You can see from this double arrow that we have this reaction is reversible. So which of the following cases will favor the production of this AB2 and B2 more? Now, very, very importantly, whenever you are having a gaseous reaction. Whenever you're having a gaseous reaction, you find out that what affects gaseous reaction more is pressure. Very, very important. You need to take note. If you're looking at this reaction, you see that you're having the AB2 is a gas, this is also a gas, and the product is also a gas. So this reaction is going to be affected majorly by pressure. So is it going to be decrease in pressure or increase in pressure? Now the answer is actually a decrease in pressure. That's what is going to affect favor the backward reaction. Now why will decrease in pressure affect the favor the backward reaction? Now when you are having this very reaction 2AB2, which is gas, like I told you, gaseous reaction or reaction involving gaseous reactants and products is majorly affected by pressure. Then you have B2 gas, then you have reversible to give 2AB, which is also a gas, and having the overall heat of reaction to be equal to minus X, we don't really know the value, minus S kilojoule per mole. So in a reaction like this, you have to check the one with the bigger volume, the side, which side has bigger volume. Here we have the volume here is 2 plus, here is 1, though it is not written, 2 plus 1, and it's giving us here 2. So the total volume here is 3, and the total volume here is 2. So this has the bigger volume, and decrease in pressure favors the side with higher volume, which is the reactant side. So we can actually say that decrease in pressure, which is what we picked as the answer, actually favors the side with the higher volume. And in this case, which side is with the higher volume? It is actually the reactant's side. So this is the reactant side, and this is the product side, and you can see the volume here is 2 plus 1. There's 1 here that is not written, which is 2 plus 1, 3, whereas the volume here is just 2. So this is the larger volume, and decrease in pressure is going to favor this very side of the reaction. So that is why decrease in pressure is the answer to this problem. This very topic you can see and read more under Electrolysis principle. So check out Electrolysis principle in your textbook. You'll be able to know how
We're going to
pressure,
start it off with a bit more of a basic glitch effect where it's just on regular text.
temperature. You'll be able to know how pressure and temperature affects a reaction, moving into either the reactant side or the product side, and also other factors like catalyst and all the rest of them. So check out your textbook, check out Electrolysis principle. You'll be able to understand what I'm saying more on these. Yeah, please, if you like this, please hit the subscribe button. Thank you. God bless you. Hello, welcome. Let's look at this question number 13 for WAEC, past question chemistry 2018. And the question goes, what is the mass of solute in 500 cm cubed of 0.005 mole per dm cubed H2SO4. Given that H is equal to 1.0, O is equal to 16.0, and S is equal to 32.0. Option A, 0.490 gram. B, 0.049 gram. C, 0.245 gram. D, 0.0245 gram. So how do we go about solving this very problem? Now, to solve this problem, first of all, we're going to look at this. We're going to take it in this way. Given that we have 500 cm cube, that is this 500 cm cube, and this very 500 cm cube solute is found inside what? 0.005 mole per dm cubed. That is this. Now, for us to have saturation, we need to have 1000 cm cubed. Now, in what mole per dm cubed are we going to get this? So let's call it X mole per dm cubed. Now, in order for us to get X mole per dm cubed, we have to cross multiply. So we can now have this 1000 times this 0.005 all over this 500. And this will give us the molar concentration, which is 0.010 mole per dm cubed. So that's the molar concentration for 1000 cm cubed. For 500, we have 0.05 as it's given here. But for us to find the mass of the solute, we need to take for 1000, and that will give us X. So making X the subject of the formula, we can get this as the molar concentration. Now, using the formula that molar concentration is actually equal to mass in gram per dm cubed all over molar mass, which is in gram per mole, of the H2SO4. So that is the relationship. So given this as the relationship, we can say that the mass in gram per mole, you don't actually know what is it. You don't know what is mass in gram per mole, which is what you are told to find. But the molar mass of H2SO4 you know, and that is molar mass of H2O4 is 1 times 2. Why do we have 1 times 2? Because hydrogen here is 1 and we have it as H2, so there are 2 hydrogens, so you have 1 times 2. Now after 1 times 2, we're going to have plus S. We've taken care of H2. S, what is S? S from here is 32, so I'm going to have 32 times how many S? We have only one S, so times 1x. Now we've taken care of X. Then let's look at the oxygen in the H2SO4. From here we can see that O is equal to 16, So we now have what here? We now have 16 into brackets. How many O do we have? 4. You can see it here. We have 4. So we write 4 here. So we'll now get this whole calculation. So this will give us x over, now 1 times 2 is 2, plus 32 times 1 is 32, then plus 16 times 4, which is 64. So we have 2 plus 32 plus 64, and that will give us 98. So that's what we have there. So in essence, we have molar concentration. What is molar concentration? Molar concentration is 0.010, which is what we actually got here. And it is equal to the mass, which we don't know. We are going to calculate this mass all over 98. So if we cross multiply, we are going to make mass the subject of the formula. So making mass, we have mass is equal to, mass is going to be equal to 0.010 times 98. So if we do this 0.010 times 98, we are going to get 0.490 gram. And that is the answer for this problem. So the answer is A, which is 0.490. So that is how you go about it. So you see the way we went through it. What is the molar concentration for 500 cm cubed? It is given. The molar concentration is 0.005. Now, any calculation in this formula, you need to get the molar concentration for 1000 cm cubed. So given that the molar concentration for 500 is 0.005, that of 1000 will be x, making x the subject of the formula, will get it to be 0.010. So that is molar concentration. And the formula says that molar concentration is equal to mass concentration all over molar mass. So mass concentration you don't know, or the mass of the solute you don't know. So over molar mass you calculate considering the substance you are having. You have H2 and H is 1 here. So since it's H2, we have 1 times 2 plus S is 32, which is given here. Since it's 1 here, it's only 1. We have 32 times 1 plus O. O is from here is 16. And since it's 4 here, we have 16 times 4. If you add everything up, you have 98. So we have the molar concentration is equal to mass over 98. So making mass the subject of the formula, we have 0.010 times 98, which will give us 0.49. So that is how we go about this. Please, if you like this, hit the subscribe button by this side of the screen. Thank you, and God bless you. Hello, welcome. Let's look at this problem. WAEC 2018 chemistry question 14. Pure water can be made to boil at a temperature lower than 100 degrees Celsius by option A, reducing its quantity, B, decreasing the external pressure, C, distilling it, D, increasing the external pressure. So, how can you make pure water to boil at a temperature lower than 100 degrees Celsius? Is it by A, reducing its quantity, B, decreasing the external pressure, C, distilling it, D, increasing the external pressure? So what is the answer to this problem? The answer is actually B, decreasing the external pressure. Why is B, decreasing the external pressure, the answer? It is the answer because pure water can actually be made to boil at less than 100 degrees Celsius if the pressure of the atmosphere, and this pressure of the atmosphere is actually the external pressure. So if the external pressure is reduced, then you can have pure water to boil at a temperature less than 100 degrees Celsius. So by decreasing the external pressure, in this case the external pressure is actually the atmospheric pressure. When you decrease this pressure, when you get this pressure reduced, then you can have pure water to boil at a temperature lower than 100 degrees Celsius. So that is a fantastic way of getting it to boil at a temperature that is lower than 100 degrees Celsius by reducing the external pressure. You have to reduce the external pressure. That is how you go about that. So you can actually find this under effects of pressure on boiling point. Effects of pressure on boiling point. How pressure affects the boiling point of substances. When you check it up, you're going to see that for a pure water, that it can actually boil at a temperature that is lesser than 100 degrees Celsius if the external pressure is reduced. So that is the answer to this problem. Please, if you like our video, always hit the subscribe button by this side of the screen. If you have any questions and concerns, drop it in the comment section. Thank you and God bless you. Hello, welcome. Let's look at this problem for chemistry, question 15, WAEC 2018. Consider the following sketch of the solubility curve of some substances. This is the sketch. You can see solubility in mole per dm cube. You can see the different substances: NaNO3, KNNO3, Cl, KClO3, NaCl, KCl. You can see these are the substances, and this is the temperature axis. Now, at what temperature does the solubility of KNO3 equal that of NaO3? Option A, 0 degrees Celsius, B, 20 degrees Celsius, C, 30 degrees Celsius, D, 40 degrees Celsius. So at what temperature is the solubility of KNO3 equal to that of NaO3? Now, if you look at the solubility curves, now you're going to identify where there is intersection between the solubility curve of the KNO3 and that of the NaNO3. So you can see that this is NaNO3. This is the curve. Then for KNO3, this is the curve. This line is the curve for KNO3, whereas this line is the curve for NaNO3. So this is the point of intersection. This is where the two curves intersected. So if you trace this point of intersection down, you're going to see that it is actually at the temperature of 20 degrees Celsius. So the answer here is B, 20 degrees Celsius. So why is it B? Because the curve for KNO3, which is this, and the curve of NaNO3, which is this, intersected at this point. So at this point they are having the same solubility. If you trace it this way, you get the solubility in mole per dm cubed. But if you trace it down, you're going to get the temperature, which is 20 degrees Celsius. So that's why B is the answer to that problem. So that is it, please. This is how solubility curve is. It's actually solubility against temperature. So when it is drawn for different substances, as it is done here, you can actually compare their solubilities at various temperatures, and that is what we've done here. Your ability to read the solubility curve is what you are being tested in this very question. So you can actually get the solution to this and see such curves under solubility in your textbook. So check for solubility in your textbook. You can look at solutes, solutions, and solubility in your textbook. You'll be able to see this solubility curve, so you'll be able to learn how to read the solubility curve, and with that you can be able to handle questions like this effectively. Please, if you like this, hit the subscribe button by the side of your screen. Thank you, and God bless you. Hello, welcome. Let's look at this question for chemistry 2018. Question number 16. When salt is added to its saturated solution, the salt, option A, dissolves and the solution becomes supersaturated. B, dissolves and the salt becomes unsaturated. C, precipitates and the solution remains unchanged. D, dissolves and crystals are formed. So what is the correct answer to this question? That when salt is added to its saturated solution, what happens? Is it that the salt dissolves and the solution becomes supersaturated? Or is it that it dissolves and the salt becomes unsaturated? Or is it that the salt precipitates and the solution remains unchanged? Or is it that the salt dissolves and crystals are formed? So what happened, or what happens when salt is added to its saturated solution? So the right answer here is C. And why is C the right answer? So the right answer here is C. Precipitates and the solution remains unchanged. And why is this the answer? That is the answer because when salt is added, this is a known fact that whenever salt is added to its saturated solution, whenever you add a salt to its saturated solution, what happens? The salt remains unchanged. So the salt actually remains unchanged, and what then happens? It deposits in solid form. It remains unchanged, but it deposits in solid form, and this deposition in solid form is known as precipitation. So it precipitates. So that is what happens whenever you add a salt to its saturated solution. It remains unchanged, but then it precipitates. So it does what? It precipitates. So that's what happens whenever you add a salt to a saturated solution. Please, if you like this, hit the subscribe button by this side. And this topic can be gotten under salts, acid, base, and salt in your textbook. Acid, bases, and salts. Thank you. Yes, let's look at this question number 17 for chemistry, WAEC 2018. When substance X was added to a solution of bromine water, the solution became colorless. S is likely to be option A, propane, B, propanoic acid, C, propine, D, propanol. So when you add substance X to a solution of bromine water, the solution became colorless. X is likely to be. So what is the added to bromine water that produces a colorless substance? So what is supposed to be the answer? So the answer to this is C, propine. Propine is the answer to this. And why is propine the answer to this? Because X is propine, because bromine water is yellow. Whenever an alkyne is added to that bromine water, it decolorizes the bromine water. And this is because of the double bond of the bromine. So we say that X is propine. Why? Because actually bromine water is yellow. That is the normal color of bromine water. Now, it is a known fact that alkyne can decolorize bromine water. So it is a known fact that alkyne turns the yellow color of the bromine water to colorless. And this is actually because of its double bonds. We all know that alkynes have more than one bond. Not actually double bonds, but triple bonds. So actually this is because of its multiple bonds. So because of the multiple bonds of the alkyne, it can decolorize bromine water, changing the yellow color. So we change this yellow color to what we call colorless. So the answer is propine. It's one of the characteristics of propine properties, the ability to change the yellow color of the bromine water to colorless. So that's why X is propine. That is the answer. Please, if you like this video, hit the subscribe button by this side of the screen. Thank you, and God bless you. Now let's look at this problem for WAEC Chemistry 2018, question number 18. The preferential discharge of ions during electrolysis is influenced by the option A, mechanism of electrolysis, B, electrolysis reactions, C, nature of the electrode, D, type of electrolytic cell. So you can actually find this topic under the factors that affect the preferential discharge of ions during electrolysis. And we all know that the factors that affect the preferential discharge of ion during electrolysis are: 1. Concentration of the ions. Concentration of the ions in the electrolyte. Number 2, the position of the ion in the electrochemical series. And finally, number 3, the nature of the electrode. So these are the factors that affect the preferential discharge of ion during electrolysis. And from this, we can see that the right option here is option C, the nature of the electrode. So I gave these other points so that we'll be able to, in case if we see this question in another form, the factors that affect the preferential discharge of ion during electrolysis are the concentration of the ion in the electrolyte, the position of the ions in the electrochemical series, and the nature of the electrode. So C is the answer. Please, if you like this, hit the subscribe button by this side of your screen. Thank you, and God bless you. Now, let's look at this question 19 for the WAEC 2018 chemistry pass question. The valence electrons of magnesium with the atomic number 12 are in the option A, 3s orbital, B, 2ps orbital, C, 2s orbital, D, 1s orbital. So in which of these orbitals is the valence electrons of magnesium found? So let's go through this. Now, the answer to this is actually A. It is in the 3s orbital. Why is it in the 3s orbital? Because magnesium has the electron configuration of, this is the electron configuration of magnesium, 1s2, 2s2, 2p6, 3s2. So you can see that the last, the valence electron is the 3s. That the valence orbital is the 3s, and the two valence electrons are on the 3s. So if you add up these electrons, you're going to see here we have, in the 1s we have 2. So if you add up the electrons in the shells or in the in the shells. We have 2 plus here we also have 2 here, plus here we have 6, plus here we have 2. So you're going to have 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12. And you see that the number of electrons, which is the atomic number as indicated here, is 12. So it's actually 12 here. So we have 1s2, 2s2, 2p6, 3s2. So the shell or the orbital that has the valence electron, which is 2, is actually 3s. And that's why the 3s orbital here is our answer. So to solve problems like this, you need to write down the electronic configuration and know that we have 1s, after 1s we have 2s, after 2s 2p, after 2p 3s, and so on and so forth. So the valence electron is these 2, which is the electrons. The valence electrons are the electrons on the atomos shell. So it is actually 2, but it is actually found in the orbital 3s. So that is the orbital. You can find this topic under electronic configuration in your chemistry textbook. So check electronic configuration in your chemistry textbook. That's where you get this. Please, if you like this video, hit the subscribe button by this side of the screen. Thank you. God bless you. Now, let's look at this question number 20 for chemistry past question for 2018 WAEC. Stainless steel is an alloy comprising of option A, iron and carbon. Actually, in this question, we can be seeing this C as chromium. I think this is actually a mistake. It should be chromium. Well, in any case, I'm going to still explain how we arrived at the answer. So let's see C as chromium. So option A, iron and chromium. B, iron and nickel. C, iron, chromium and nickel. D, iron, chromium and aluminium. So what are the components, or what are the component mixture in the alloy of stainless steel? We all know that the alloy of stainless steel is composed of the following. So we have our stainless steel. It is actually made up of iron, nickel and chromium. These are the major components of stainless steel. Now, in some cases, it can have very small amount of carbon actually, but the major elements that are in the stainless steel alloy are iron, which we all know is Fe, nickel, which we all know is Ni, and then chromium. In this case, they represented it as C, but we all know that carbon is C. So we can also say that this is chromium. Carbon is C, but we can say that we have that C. Even if this C is chromium or carbon, it is the answer for this, because all these other ones, they don't have, most of them have, this one has iron, this one iron, this one iron, this one iron, but this time around this one does not have nickel. This one has both nickel, carbon or chromium, and this one has aluminium, and you know aluminium is not part of the mixture. So that makes C the right option. But know that stainless steel is composed of iron, nickel and chromium. So those are the components of stainless steel. Then it can also contain some little amount of carbon. So that makes it the answer to this question. Please, if you like this, hit the subscribe button by the side of the screen. Thank you, and God bless you.
Yes, welcome. Let's look at question number 21 for the chemistry past question, WAEC 2018. The number of hydrogen ions in 1.0 dm cube of 0.02 mole per dm cube tetraoxosulfate 6 acid is given Avogadro's number as 6.02 times 10 to the power 23. Option A, 1.2 times 10 to the power 22. B, 1.2 times 10 to the power 23. C, 2.4 times 10 to the power 22. D, 2.4 times 10 to the power 23. So how do we go about solving this? How do we go about solving this? Now, the answer to this problem is A, 1.2 times 10 to the power 22. So let's take down how we get to this. Now, we all know that 1 mole of any substance contains 6.02 times 10 to the power 23 ions, which is the Avogadro's number. That's what 1 mole contains. So 1 mole is a quantity that is equivalent in terms of ions, this number. So now 0.02 mole per dm cube, what is it going to contain? So if we now have 0.02 mole per dm cube, how many ions is it going to contain? Let's call it S, number of ions. So to calculate this X number of ions, we can cross multiply this and this, so that we have 0.02 times 6.02 times 10 to the power 23 all over 1. So this X number of ions, which is actually what we're looking for, is equal to, so if we solve this out, you're going to be having, instead of having 0.02, you can say that you have 2.0 times, if you take this over, you have 10 to the power minus 2. So another way of saying 0.02 is 2 times 10 to the power minus 2. So you continue times 6.02, which you already had, times 10 to the power 23. So if you solve this down, you can have 2.0 times 6.02 times this very one, 10 to the power minus 2 times 10 to the power 23. We are solving it like this because in case if we are not using calculator, this is equal to 2.02 times 6.02 will give us 12.04. So times by indices, this times this is going to be minus 2 plus 23 with 10 as the base. You have this minus 2 plus 23 is going to give us plus 21. So that's what we have. And this now we can say is the same thing as 1.204 times 10 to the power 22. So having this now, we can actually approximate this to 1.2 times 10 to the power 22. So this is the answer to this problem, and this is actually option A. So that's how we come about this option A. So you can actually see this under moles. You check my lectures under moles. So that's why you can see this, get this. So you can look at the procedure that we use in sorting. It's very self-explanatory. They are telling us that the number of hydrogen ions in 1.0 dm cube of 0.02 mole per dm cube of tetraoxosulfuric acid is what? We know that 1 mole contains 6.02 times 10 to the power 23 ion, which is the Avogadro's number. So that is the definition of what a mole is. So we are supposed to know that. But in this time around we are given 0.02 mole per dm cube and not 1 mole per dm cube. So this 0.02 mole per dm cube is going to give us X number of ions. So making X the subject of the formula, you cross multiply this and this so that you have X is equal to 0.02 times 6.02 times 10 to the power 23 all over 1. So instead of having 0.022, if you change this to standard form, you have 2.0 times 10 to the power minus 2. Now you bring down this 6.02, 10 to the power 3, 10 to the power 23, bring it down to. So now you take like terms together, 10 to the power minus 2 and 10 to the power 23, take them to one side, you have this one side. So 2.0 times 6.02 will give us 12.04. Now, since the base are the same, we have 10 here, 10. So you can simply add up the index. Minus 2 plus 23 will give us 21. So that's how we bring down the base. That's how we have this. Now, 12.04 times 10 to the power 21 is the same thing as saying 1 point. When you take this decimal place over to this side, 1.204 times 10 to the power 22, so that instead of having 21 you are now having 22. So this is approximately, when you take out these two, you have 1.2 times 10 to the power 22, which is the answer. Please, if you like this, hit the subscribe button. Thank you, and God bless you. Yes, let's look at this question number 22 for chemistry, WAEC 2018. The most suitable substance for putting out petrol fire is option A, water, B, carbon 4 oxide, C, fire blanket, D, sand. This is a pretty easy one. The answer is carbon 4 oxide. If you check your textbook under the uses of carbon 4 oxide, you find out that carbon 4 oxide is the most suitable substance for putting out petrol fire. Why? Because it is actually denser than air, so it cuts off oxygen supply to the burning material, making it very effective as an extinguisher. So it is used as an extinguisher. So take note, CO2 is used as fire extinguisher. Why? Because it is denser than air, and it does what? It cuts off oxygen supply to the burning material. You know that oxygen is needed for burning to happen, or for fire to happen. So because CO2 is dense, so it's better than any other thing to be used in putting out petrol fire. So it's better than water, it's better than sand, because the materials for burning, they can float on water and sand. They can float on water, so it's better you use carbon 4 oxide, CO2. That's the best thing to use for putting out petrol fire. So please check this under uses of CO2, carbon and its compound. Check under uses of CO2, under carbon and its compounds in your textbook. That's where you find it. Please, if you like this video, hit the subscribe button. It's by this side of your screen. Thank you and God bless you. Yes, let's look at this question number 23 for WAEC Chemistry 2018. The following factors would contribute to environmental pollution except option A, production of ammonia, B, manufacture of cement, C, photosynthesis, D, combustion. We can see that the answer is clearly C, photosynthesis. Photosynthesis does not cause environmental pollution. So the answer to this problem is C, photosynthesis. The other chemical processes like production of ammonia, manufacture of cement, and combustion, all of them release toxic waste into the environment. So they cause environmental pollution. But photosynthesis does not cause that. So what is this photosynthesis that we say does not cause environmental pollution? What is photosynthesis? This photosynthesis is actually a process by which photoautotrophs. What do we mean by photoautotrophs? Photoautotrophs are actually plants which are, I think the proper thing is that are plants that are sensitive to light. They are known as photoautotrophs. So they use this light to do what? To generate their energy. So you cannot say that this contributes to environmental pollution. So actually you have the plants using light to generate energy in a process known as photosynthesis. So these plants are always green plants. So they use light, that's why it is known as photo, to generate energy. So photosynthesis is a process that does not contribute to environmental pollution. Please, if you like this, hit the subscribe button by this side of your screen. Thank you and God bless. Hello, welcome. Let's look at this chemistry question 24 for WAEC June 2018. The position of equilibrium in a reversible reaction is affected by A, particle size of reactants, B, vigorous stirring of the reaction mixture, C, presence of a catalyst, D, change in the concentration of the reactants. Now, to solve this problem, it is very important that we note the factors that affect the equilibrium, position of equilibrium for a reversible reaction. So we look at factors that affect equilibrium position. So what are these factors that affect equilibrium position? Number one, concentration of the reactants. So this changes to concentration already is one of the answers. Number 2, concentration of the reactants or product. So number 2 is pressure of the reactant side or product as well. Number 3 factor is temperature too. And the temperature in this case, we are talking about whether the reaction is endodermic, that is, it receives energy from the environment, or whether it is exothermic, that means it sends energy out to the environment. So these are the things that affect. So from there you can easily see that changing concentration of the reactants will actually move the equilibrium position to another place. Now, but if you're talking about factors that affect rates of reaction, you're talking about factors that affect rates of reaction, then you'll be talking about things like stirring, as we have in number B. We're talking about things like particle size, because we need a greater surface area for reaction, particle size. Then you're talking about things like catalyst, presence of catalyst. So you can see that these 3 points are for rate of reaction, which are for all these other ones. Apart from this D, which is actually for equilibrium position. So take note of all this. You can get this under Legittilia's principle or equilibrium in your textbook. Thank you for listening. God bless.
Hello, welcome. Let's look at this question number 25 for WAEC past question, chemistry. The diagram illustrates a conical flask containing water and ice. Which of the following statements about the diagram is correct? A. The water is at lower temperature than the ice. B. Energy is absorbed when the ice changes to water. C. Energy is released when the ice changes to water. D. The water molecules vibrate about a fixed point. So, which is the answer to this? From what is read now, B is actually the answer, because energy is absorbed when the ice changes to water. Ice is in solid form. You need energy to make it to be in liquid form. So that makes that the answer. Now, how do we eliminate the other answers? Now you have that the water molecules vibrate about a fixed point. This is not true. Why is it not true? Because this is what happens for solid, but water is liquid. So you cannot say that the molecules vibrate about a fixed point. This is what happens for solid. So that makes this answer not to be true. Now, the first one says that the water is at lower temperature than the ice. It can never be true, because you know that ice has very low temperature. Like when you go to tropics, like in Russia and other places where you have snow falling, the temperature is very cool because of ice, unlike where you have water. So the temperature of ice cannot be higher than that of water. So that of water cannot be lower than that of ice. So that makes this incorrect. Then when you look at C, energy is released when the ice changes to water. That is wrong, because you actually need energy for you to change a solid to liquid. You understand? So this is also not correct. So that makes B the answer to the question, that energy is absorbed. You need energy. Once you add, if you want to also learn about this, just put ice block inside something, then apply heat, apply energy in form of heat. So once you apply energy, you find out that this very ice block will change to water. So you need heat to do that. So energy is absorbed. So this system will absorb energy. This system will absorb energy. Energy is absorbed to change this ice to water. So that makes option C the correct answer. So I hope it is very clear. So this is actually an endothermic process because there is reception of energy. So it's actually an endothermic process because there is reception of energy. Thank you. Now let's look at question number 26 for WAEC Chemistry 2018. Which of the following statements best explains the difference between gas and a vapor? A. Unlike gases, vapors are liquids at room temperature. B. Unlike gases, vapor can easily be condensed into liquids. C. Unlike gases, vapor is readily converted into solids. D. Vapor are generally denser than gases. So how do we go about this? Now, I can actually use the elimination method to put this out. Looking at the statement, which of the following best explains the difference between a gas and a vapor? So what is the major difference between a gas and a vapor? Is it that vapor are generally denser than gases? That is not true. This is not true. It actually depends. Some gases have high density. So both of them are actually in gaseous form. Both gases and vapors are classified under gaseous state of matter. And you know we also have the liquid state and we have the solid state of matter. So, but vapor and gases are classified under the same testing. So now let's look at other options. Unlike gases, vapor is easily converted into solid. This is not true. I think vapor can actually be easily converted to liquids. So unlike gases, vapor can easily be condensed into liquids. I think this is very close to the answer or the correct answer. Now we have unlike gases, vapor are liquids at room temperature. Looking at this, unlike gases, vapors are liquid at room temperature. No. Because even at room temperature, you can still have vapor in still gaseous phase. You can have substances in gaseous phase. You understand? So it's not this, even at room temperature, you can have a vapor. So this is not the correct answer. So this makes B the most likely answer, or you can say the correct answer. Unlike gases, vapor can easily be condensed into liquids. Yeah. So when you have your vapor, once you reduce the temperature, you can easily convert them to liquid. So that is it. So please, you can actually check this out on the states of matter, on matter as a topic, the initial topics in chemistry. That's where you get this. Thank you and God bless you. Now let's look at this question number 27 for chemistry, WAEC 2018. Consider the following reaction equation 2HCl plus CaOH2 to give us CaCl2 plus H2O. What is the volume of 0.1 mole per dm cubed HCl that would completely neutralize 25 cm cubed of 0.3 mole per dm cube CaOH? Now, from this, you are told to calculate the volume that will completely neutralize 25 cm cubed of 0.3 mole per dm cube of this base. Option A, 150 cm cubed, B, 75 cm cubed, C, 30 cm cubed, D, 25 cm cubed. Now, how do you go about solving this? Now, before you start solving this, it's very important that you know that this is the acid. This is the acid. HCl is acid, and this is the base, because this is calcium hydroxide. So this is the acid, this is base. Now you can actually find this topic or be able to solve it under titration, or broadly under the topic known as neutralization. And neutralization can be found in our normal textbooks under acid, base, and salt. Because if you look at this is typically acid-base reaction. This acid reacting with this base, HCl is the acid, reacting with calcium hydroxide base to form calcium chloride, which is a salt, and water. So this type of reaction is known as neutralization reaction, and that is what actually took place. So what is the formula that you use in solving a neutralization reaction? We have concentration of the acid times volume of the acid all over concentration of the base times volume of the base equal to the molar concentration of the acid all over molar concentration of the base. So that is the formula that we are going to be using, and we are given that the concentration of the acid is 0.1 mole per dm cubed. That is what is given, because here you can see that I told us that HCl is the acid. You can see that that is the concentration given. Now we are also given that the concentration of the base is 0.3 mole per dm cubed. That's concentration of the base, and it is clearly here. I told us that CaCO2 is the base. This is where I indicated it as the base, and this is the concentration given, which is 0.3. Now we look at volume of the base. Is it given? Yes, it is given. Needed to neutralize 25 cm cube of the base. So this is the volume of the base, which is 25 cm cubed. Now, what else do we have? We also have that Na is equal to 2. Na. So the number of moles for acid, you can see that it is 2 here. So that's why we have 2. And we also now have that Mb. This is Na. We also have that Mb, number of molecules or number of moles of the base. You can see that nothing is written, so it's automatically 1. So we have 1 here. So putting this in the equation, in this very equation, putting all these in this very equation, we have Ca is what? 0.1 times Va. Va is what? Va is unknown. That's what we are looking for. So we are looking for Va all over Cb, already given, is 0.3 times Vb, which is volume of the base, 25, equal to Na, number of moles of acid is 2, all over number of moles of base is 1. So when we cross multiply and make Va the subject of the formula, we now have Va to be equal to, so we have every other thing around here, which is 0.3 times 25 times 2 all over the things that are with Va, which is 0.1 times 1, which is also 0.1. So if we multiply out, we are going to be having 15 all over 0.1.
which is equal to 150 cm cubed. So the answer here is equal to what? 150 cm cubed. So that makes that the answer. So the answer is actually option A, 150. So once you multiply this out, 0.3 times 25 times 2 all over 0.1, you get 150 cm cubed, and that is the answer. Thank you very much. Yes, let's look at this question number 28 for WAEC Chemistry 2018. Cu, which is actually copper, and HNO3 are not suitable for preparing hydrogen gas because of their A. Reactivity and oxidation respectively, B. Conductivity and corrosiveness respectively, C. Melting point and reduction respectively, D. Electronegativity and solubility respectively. So how do we take care of this very question? Now we can simply use the elimination method to pick out. When it says respectively, means that the very property is associated with the, like this one, reactivity is associated with Cu, copper, whereas oxidation is associated with HNO3. For this one, conductivity is associated with copper, and corrosiveness is associated with HNO3. So what are the possible properties of copper and HNO3, triazonitrate acid, that can make them not to be good for producing hydrogen gas? Is it electronegativity and solubility? We also know that this is electropositive. So can its electronegativity actually affect its reaction to produce hydrogen? This cannot be the answer. Conductivity and corrosiveness. What has conductivity got to do with hydrogen gas production? This cannot be the answer because of this. Now, melting point and reduction. I don't think there's anything reduction has to do with hydrogen gas production, especially when you combine it with melting points. So this cannot also be the answer. But reactivity and oxidation respectively. Reactivity is copper, Cu, is it reactive enough for hydrogen gas to be produced using it? So it has to be a factor to be considered. Then oxidation is also important. So this is an oxidizing agent. So can you actually use it to produce hydrogen gas without it being able to oxidize it into water? So it's a factor. Oxidation is a factor. So with that, A is very, very likely the answer. So we can now say that the two factors that will make this not to be possible is reactivity and oxidation respectively. So we can see that you have to question the reactivity of the copper, and we all know that HNO3 is an oxidizing agent. It's a very strong, concentrated one is very, very strong oxidizing agent. So it's a factor. So do you want to oxidize the hydrogen that you form immediately to H2O? When you're using an oxidizing agent like this can happen. So you will not be having enough hydrogen that you want to produce. So please, you have to study this. Please check out your textbook in the preparation of hydrogen gases, and the preparation of hydrogen gas, and you get better understanding of these. Thank you. Yes, welcome. Let's look at this question number 29 for
WAEC chemistry. Which of the following formula cannot be an empirical formula? A. CH, B. CH2, C. B2O5, D. N2O4. So which of these formula cannot be an empirical formula? Now, for you to have an empirical formula, we know that the empirical formula is the formula with the simplest ratio of the constituent elements. So it has to be the formula with the simplest ratio of the constituent elements. So which is that? Here you have 1:1 because C is 1, H is 1. Here we have 1:2 because C is 1, H is 2. Here we have 2:5 because P is 2 and O is 5. But here we have 2:4 because N is 2 and O is 4. Now, because of this ratio, you can simply see that 1:1 is in the simplest form. Here you cannot have anything that can go through and divide again for 1:2 as well. Nothing else can go through. If you divide through by 1, you still have this. If you divide through by 1, you still have this. So nothing can go here too, nothing can go through. But here, if you divide through by 2, you're going to have 1:2. So you can still bring this very D down further. You can bring it down further to have NO2. So you can actually have NO2 as the empirical formula or the formula with the simplest ratio. So that makes D the answer to this problem. So D is the right option, NO2. So first it has to be the formula with the simplest ratio. Thank you. Now, let's look at this question number 30 for WAEC Chemistry 2018. Which of the following criteria, or one of the criteria for confirming the purity of benzene, is to determine its A. Heat capacity. Please, this is a mistake. This should be heat capacity. B. Boiling point. C. Mass. D. Color. So what is the criteria for confirming purity of benzene? Now, it is very important to know the criteria for confirming purity. Criteria for confirming purity. You need to know them so that you don't get confused whenever you say this. Number 1 is what we call boiling point. For liquids, we have boiling point. Then number 2 is what we call melting point. For those in gaseous state, melting point. So these are the two major things that you use in confirming for purity, but they are not the only ones. You also have what we call you can check out the refractive index. You can check out the refractive index. These are recent discoveries for checking purity for organic compound. Refractive index. You can also check out the crystalline structure. If it is perfect, then you know that this is actually a pure substance. You can check out the crystalline structure. So these are the criteria used in checking for purity. You can also check out what we call specific gravity. You can check out specific gravity, which you can also call relative density. Specific gravity or relative density. So these are the criteria for confirming purity. So now we are looking at for benzene, which is a liquid. So we can actually say that the answer is boiling point, because that is what we use in checking for liquids. Please, this is E, this is heat capacity. So this is the answer. You can see there is nothing like mass inside this one. There's nothing like color. You can actually use chromatography also to check for some solutes, but you know it's not for liquid. It's actually boiling point. Now you have heat capacity. It's not the answer. So the answer here is B, boiling point. That is what you can use as a criteria
for checking the purity of a liquid, in this case benzene, or for such organic compounds. So we can see from the options that the criteria for confirming purity that is in the option is boiling point. So that makes B the answer to this. Hello, welcome. Let's look at this question number 31 for WAEC Chemistry 2018. When chlorine is passed through a sample of water, the pH of the water sample would be A, less than 7, B, greater than 7, C, equal to 7, D, 0. So what is going to be the answer to this problem? Is it less than 7, greater than 7, or is it equal to 7? Please, there is 7 here. Is it equal to 7, less than 7? So what is going to be the answer? So let's look at this together. Now we are told that chlorine is passed through a sample of water. This is going to give us HCl, an acid, plus HOCl. And these are, or this is a mixture of acids. These are acids, so this is a mixture of acids. So you have your chlorine reacting with water to give us mixture of acids. And we know that acids have pH less than 7. For acids, we know that if you have pH greater than 7, call it base. Now if you have pH equal to 7, we call it salt. So since we are having a mixture of acids, so this solution is acidic. And because it's acidic, it can only be less than 7. So A is the correct answer. For this is basic. So this is for acidic. This is for basic situations. This is neutral, like for salts. Neutral, like for salts. So that's what we'll have. So that makes A the answer to this question. Thank you. Yes, let's look at this WAEC question for 2018 chemistry, question 32. How many atoms are contained in 0.2 moles of nitrogen? Given that Avogadro's number N is equal to 6.02 times 10 to the power 23. A, 1.20 times 10 to the power 23. B, 2.41 times 10 to the power 23. C, 3.62 times 10 to the power 23. D, 4.82 times 10 to the power 23. Now, how do we go about this? We all know that 1 mole of every substance contains the Avogadro's number of particles, which is 6.02 times 10 to the power 23 number of particles. Now, 0.2 moles will then contain how many? It will then contain X number of particles. So make X the subject of the formula. You're going to cross multiply so that X will be equal to this times this, cross multiplying 0.2 times 6.02 times 10 to the power 23 all over 1. So how many atoms, particles in this time around is atoms? So it's going to be 0.2 times 6.02 times 10 to the power 23. So if you multiply this out, you're going to have 12.04 times 10 to the power 22, which is also equal to 1.2, because we are taking this point here over to this side, putting in standard form. 1.204 times 10 to the power 23. So when you take these points here, you now make this to be 23. So, and this is the answer to the problem. So from the options, you can see that we also have 1.20 times 10 to the power 23 here. So this is approximately 1.20 times 10 to the power 23, which is the answer to this problem. And that is how we arrive to this answer. So very, very important for you to notice that 1 mole contains this number of particles, and these particles is not necessarily atoms. So it could be atoms, it could be ions, you understand? It could be any of the particles. So 1 mole of every substance contains this number of particles. So 0.2 moles will contain X atoms or ions or anything. So make that X the subject of the formula to find how many atoms. So you have to cross multiply by saying this times what is here times what is here all over what is here, which is this. So if you just do 0.2 times 6.02 times 10 to the power 23, you have this, which you can put in a refined standard format of this and approximate to this in order for you to have this. Yeah, thank you very much. Yes, let's look at this WAEC question 33 for chemistry 2018. The strength of metallic bonds depends on the A. Charge density of the atoms, B. Ductility of the metal, C. Number of valence electrons, D. Total number of electrons in the atom. So how do we solve this? We all know that when you're talking about bonds, we talked about covalent bond, ionic bond, the metallic bonds, and the rest of them. So now we are looking at metallic bonds. So whenever you're talking about bonding and you have your electronic configuration in this form,
now you have materials that you want to come together. You're going to find out that what is connecting this with this has to do with the outermost or the outer electrons. So that will cause the bonding to be there. And these outer electrons are also called valence electrons. So the valence electrons are responsible for bonds. Valence electrons. The valence electrons are these electrons on the outermost shell, the last shell. The electrons on the outermost shell. So from this explanation, we can easily say that C is the answer. So the strength of metallic bonds depends on the number of valence electrons, because they are the things that are responsible for these. So like I said before, bonds could be covalent, it could be ionic, it can also be metallic. We also know about van der Waals forces, weak forces, or weak bonds. So in essence, whether it's covalent, ionic, metallic, we always have the valence electrons playing very important part in determining the strength of the bond. So very, very important. So that makes C the correct answer to this. Thank you. Yes, let's look at this question number 35 for WAEC Chemistry 2018. The empirical formula of a compound containing 0.067 mole copper and 0.066 mole oxygen is, given that Cu copper is equal to 63.5, O is equal to 16.0. Options A, Cu2O, B, CuO, C, CuO2, D, Cu2O2. So now we are told to find the empirical formula as the formula that has the components in the simplest ratio. So how do we go about this? We are supposed to have that we have copper, then we have oxygen. Now, what is the number of moles of each that we have from the question? We have copper to be 0.067 moles. So 0.067 moles. Then we have oxygen to be 0.066 moles. So we have 0.67 and 0.66 moles. Now, we are going to check out the mole ratio. So mole ratio is, you get it by dividing by the simplest or the smallest value in the two that you're comparing to get the ratio. So you can see that 0.66 is smaller than 0.67. So we're going to divide through by 0.67. So we have 0.67 by 0.66, the smaller one. 0.67 divided by the smaller one, which is 0.066. 0.067 over 0.066. Then here we have 0.066 all over 0.066, which is also the smaller one. So this will enable us to have a ratio. So when you divide this by this, you're going to have 1. But when you divide this by this, you're also going to have 1. It's close to 1. So we have 1:1 as the ratio. So when you have 1:1, you can only say that you now have copper and you have oxygen 1:1. So you can, the ratio is 1:1. So you just have CuO as your answer. So that makes B the correct answer. That makes B the correct answer. I didn't mean you have something like 1 here and you have 2 here. So you're going to have Cu2O. So yeah, it depends on the ratio. So, and how do you get the ratio? By writing down the number of moles and dividing through by the smaller one, so that you can have 1 on one side and another thing on the other side. But in this case, we have 1 on either sides. So we don't have to put 2 or 3 or anything. So it has to be CuO, because Cu is 1 and O is 1. So that's how you go about this. Whenever you want to calculate for empirical formula, it has to be the mole ratios. I didn't mean you're giving masses, then you're then supposed to use these very molecular masses, these atomic masses, to calculate the number of moles. But the number of moles is already given, so you don't need to use this to do this calculation. You just get the mole ratio by dividing with this smaller one in the 2 moles that you're considering. In this case, it is 0.066. So if you divide through by 0.066, you're going to be having 1 here and 1 here. So this makes this the right answer to this problem. Yes, let's look at this question number 35 for WAEC Chemistry 2018. The empirical formula of a compound containing 0.067 mole copper and 0.066 mole oxygen is, given that Cu copper is equal to 63.5, O is equal to 16.0. Options A, Cu2O, B, CuO, C, CuO2, D, Cu2O2. So now we are told to find the empirical formula as the formula that has the components in the simplest ratio. So how do we go about this? We are supposed to have that we have copper, then we have oxygen. Now, what is the number of moles of each that we have from the question? We have copper to be 0.067 moles. So 0.067 moles. Then we have oxygen to be 0.066 moles. So we have 0.67 and 0.66 moles. Now, we are going to check out the mole ratio. So mole ratio is, you get it by dividing by the simplest or the smallest value in the 2 that you're comparing to get the ratio. So you can see that 0.66 is smaller than 0.67.
So we're going to divide through by 0.67. So we have by 0.6 is the smaller one. 0.67 divided by the smaller one, which is 0.066. 0.067 over 0.066. Then here we have 0.066 all over 0.066, which is also the smaller one. So this will enable us to have a ratio. So when you divide this by this, you're going to have 1. But when you divide this by this, you're also going to have 1. It's close to 1. So we have 1:1 as the ratio. So when you have 1:1, you can only say that you now have copper and you have oxygen 1:1. So you can the ratio is 1:1. So you just have CuO as your answer. So that makes B the correct answer. That makes B the correct answer. I didn't mean you have something like 1 here and you have 2 here. So you're going to have Cu2O. So it depends on the ratio. So, and how do you get the ratio? By writing down the number of moles and dividing through by the smaller one, so that you can have 1 on one side and another thing on the other side. But in this case, we have 1 on either sides. So we don't have to put 2 or 3 or anything. So it has to be CuO, because Cu is 1 and O is 1. So that's how you go about this. Whenever you want to calculate for empirical formula, it has to be the mole ratios. That means you're giving masses, then you're then supposed to use these very molecular masses, these atomic masses, to calculate the number of moles. But the number of moles is already given, so you don't need to use this to do this calculation. You just get the mole ratio by dividing with this smaller one in the 2 moles that you're considering. In this case, it is 0.066. So if you divide through by 0.066, you're going to be having 1 here and 1 here. So this makes this the right answer to this problem. Hello, let's look at this question 36 for WAEC Chemistry 2018. The change in oxidation state of iron in the reaction represented by the equation below is, the equation is 2FeCl3 plus H2S to give 2FeCl2 plus 2HCl plus S. Now, the options are A plus 2 to plus 3, B plus 2 to plus 2, plus 3 to plus 2, C 0 to plus 2, D plus 3 to 0. So, which is the change in oxidation state of iron in the reaction represented by the equation below? So, how do we go about solving this? Now, we know that to solve for oxidation state, say for FeCl3, the oxidation state should always be equal to 0 for a neutral substance or for a compound that is not charged. For a compound that is not charged, the oxidation state is equal to the general oxidation, the addition of the sum of the oxidation is equal to 0. So, and we don't know that for Fe, but we know that the oxidation, this number for Cl is -1, and since there are 3 Cl, we have times 3, so equal to 0. So if you have the summation of the oxidation number of the ion plus that of the chlorine will give you 0. But you don't know that of the ion, so you write Fe. Then you have minus 3 times, minus 1 times 3 to give us minus 3 equal to 0. So the oxidation number of Fe here is 3, because 3 going over will become plus. And that's why this is iron trichloride, because it is 3. Now let's check the oxidation number of iron here. So this is plus 3 here. You can put plus or you can just write 3. Then for this one, we also have FeCl2 equal to 0. The summation is 0. So we now have the oxidation number of iron plus that of Cl, chlorine. The oxidation number of chlorine is minus 1. Or because it is 2, we multiply by 2 equal to 0. So we now have that the oxidation number of iron minus 1 times 2 will give us minus 2 equal to 0. So making the oxidation number of iron the subject is equal to this. Going over to this side will become plus 2. So you can see that the oxidation number of iron here is plus 3, but here it is plus 2. So this change is actually from plus 3 to plus 2. And the option that has that is B, from plus 3 to plus 2. So that is how you calculate the oxidation state of elements. Whenever they are in form of compound, the summation of the oxidation numbers is always equal to 0. So you use the one that you already know to find the one that is changing. So that is how we go about this. Thank you.
But it's not like this is the challenge I'm not doing. I give it a background color. Now to have the background color.
Hello, welcome. Let's look at this question number 37 for WAEC Chemistry 2018. Which of the following methods can be used to separate blood cells from plasma? Option A, centrifugation. B, filtration. C, chromatography. D, distillation. Now, how do we go about solving this? For us to be able to understand this, we need to give the definition for these various separation techniques. So let's look at the first one, centrifugation. What is this centrifugation? Centrifugation is a separation technique used for separating substances mixed due to their varying or due to their difference in viscosity or density. So that is what centrifugation is. Separating substances mixed. And this separation is due to their varying viscosities and density. This is very close to what we have here. The blood cells and the plasma have varying viscosity and density. So the answer is going to be A, centrifugation. But as a matter of differences, now let's look at the definition of filtration. Filtration is actually a separation technique that is used for separating substances of varying size. Filtration is used for substances of varying sizes and shapes. So this cannot be the answer to this problem.
Now we look at the third one, which is chromatography. Chromatography is a separation technique that has to do with solute movement. Solute movement in a chromatographic paper, and this will not be good for this. Then finally, we look at distillation, which is actually a separating technique for substances of varying boiling points. Substances of varying boiling points. So these three cannot be the answer to this problem, but centrifugation is what we can use, which is a machine that looks like this. It has tubes. So inside these tubes you have your plasma and your blood cells. So when there is movement of these tubes in a circular path in a centrifuge, there will be separation. The ones of bigger density will go down here, whereas the ones of lesser density will be up here. So once there is this separation, you cannot decant to have your biggest density one separated from this one, or the bigger viscosity one from the one of lesser viscosity. So that is how you can use centrifugation to do separation. So centrifugation is the best method to separate blood cells from plasma. Thank you. Let's look at this question number 38 for chemistry WAEC 2018. Which of the following statements about ionic radius is correct? Ionic radius A increases as nuclear charge increases. B decreases as nuclear charge increases. C decreases as nuclear charge decreases. D remains constant as nuclear charge increases. So, what is the right explanation for this? Now, when you talk about ionic radius, the radius of the ion, what has it to do with the charge? Of that very ion. Now we can make this statement that ionic radius decreases as nuclear charge increases. Very, very important. Once there is more charge, once there is more nuclear charge, it is going to attract this very radius. It will shrink the radius. It will go down because of the power of this charge. This charge, the charge inside this nucleus is so powerful that if it is very big, because the electrons are negative, whereas the protons are positive, there is this force of attraction between the two of them. So if there is big charge here in the nucleus, it will attract and shrink the radius. So this very radius is going to be reducing. So ionic radius actually reduces or decreases as nuclear charge increases. So the more powerful the nucleus, the lesser the radius. Because of the attraction, it will attract it down and shrink the radius. So instead of the radius being as big as this, the force of attraction here will shrink it down, so it will now be smaller. So that is why the answer to this question is B, that ionic radius decreases as the nuclear charge increases. Thank you. Let's look at this question number 39 for WAEC Chemistry 2018. Analysis of a hydrocarbon shows that it contains 0.93 gram of carbon per gram of the compound. The mole ratio of carbon to hydrogen in the carbon is, given that H is equal to 1.0 and C is equal to 12. Option A, 1:1, B, 1:2, C, 2:1, D, 2:3. Now, how do we go about this? Let's pick this one by one. We say that the analysis of a hydrocarbon, whenever you hear the word hydrocarbon, it simply means that you're talking about hydrogen and carbon. Now, the analysis shows that 0.9 gram, it contains 0.9 gram of carbon. So for this carbon, we are going to have 0.93 gram of carbon per gram. Per gram, whenever you hear the per gram, it simply means per 1 gram. So 1 gram of the compound. So if there is 1 gram of the compound and 0.93 is carbon, the remaining should be hydrogen because it is hydrocarbon. So that remaining should be 1 minus 0.93, and that will be what? That will be 0.07. So how did we get this 0.07? By simply saying 1 gram of the hydrocarbon minus what is carbon there, which is 0.93, you get this 0.07. So that is what we have. Now, in order for us to know the mole ratio, we need to divide through by the smaller one in order for us to know the mole ratio. But before we divide through by the smaller one, to convert the gram to mole, we need to divide by these numbers as is given here. So for carbon, the atomic number and the mass number for this carbon is 12. So we are going to have 0.93 all over 12 in order to convert it to mole from gram. Then this one, the mass number is 1. We are going to have 0.07 all over 1. The atomic mass is 1. So if you do 0.93 over 12, what are we supposed to get? If we do 0.93 over 12, we'll be able to get 0.0772. Then if you do 0.07 over 1, we still get 0.07. So that is what we get. Now, to get the mole ratio, we need to divide through by the smaller one. The smaller one here is 0.07. So if you do this 0.0772 all over 0.07, then you also do 0.07 all over 0.07 because you are dividing by the smaller one. So if you divide this, you're going to have 1. If you divide this, you're also going to have 1. So we have 1:1 as the ratio. So the answer becomes A, 1:1. So you can see the process that we went through in order to arrive at this. First of all,
the quantities given to us are in grams, so we'll convert to mole first by dividing by the atomic masses of the different one. And the atomic masses are already given. For hydrogen is 1, for carbon is 12. So divide the 0.93 by 12 and 0.07 by 1. Then anything you have, check for the smallest and divide through by the smallest, then you get the actual ratio. So that is how you solve this. Thank you. Now let's look at this question number 40 for WAEC Chemistry 2018. The law of definite proportions states that A. Pure samples of the same compound contain the same elements combined in the same proportion by mass. B. Pure samples of substances are in the same proportion by mass. C. Chemical compounds are pure because they contain the same elements. D. Matter can neither be created nor destroyed. So when you check out this textbook on the laws of chemical combination, we'll be able to see that we have some laws there. We have number 1 law, the law of conservation of mass, which says that matter or mass, law of conservation of matter, matter cannot be created nor destroyed. That is this. So this cannot be the law. So we also have the laws, other laws like law of definite proportion, law of other laws. So, but the one that we are considering today is the law of definite proportions. And what is the statement of this law? The statement is that pure samples of the same compound contain the same elements combined in the same proportion by mass. That is the statement of the law of definite proportion. And that makes A the correct option and answer. This other two, pure samples of substance are in the same proportion by mass. This is wrong. And also chemical compounds are pure because they contain same element. This is also wrong statement and cannot be said to be attributed to this law of definite proportion. So the right statement of the law of definite proportion is that pure samples of the same compound contain the same elements combined in the same proportion by mass. So if you have pure sample of HCl, whether you're getting it here or you're getting it in America, you bring another pure sample of HCl and you got it from your village. Provided that both of them are pure, the proportion of combination, if it is 1:1 for this one, the one you got in the USA, it will also be 1:1 from the one you got from China. So the mass proportion has to be the same, no matter where they are from, provided that they are pure. Provided that they are what? Pure. Very, very important. Provided that they are pure. Thank you. Let's look at this question number 41 for chemistry, WAEC 2018. What is the relative molecular mass of a compound which has empirical formula CH2O, given that H is equal to 1, C equal to 12, and O equals to 16. Option A, 42, B, 45, C, 126, D, 180. So how do we go about solving this very problem? Given that the empirical formula is CH2O, First of all, we need to calculate the relative molecular mass of what we have here. And C from here, we know that C is 12. So we write 12 plus, we know that H is 1. So we write 1. But because there are 2 H, we have times 2. Now, O, we know is 16. That means we've gotten the whole of it. So we'll get the summation. 12 plus 2 is 14. 14 plus 16 is 30. So that is what we have. And we all know that we can have C H2O into bracket N, which will give us the relative molecular mass, the real relative molecular mass of this, given that this is the empirical relative molecular mass for this. So how do we get about getting our X? Now, CH2O we already know is 30. So we are going to multiply it by N in order for us to get this relative molecular mass that we are looking for. And we all know that this N is actually always an integer. It should be an integer, which can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6 or so. So it can be any number that is an integer. It has to be a whole number. So we try to multiply with this to see what we'll have as the answer. Now, if we assume that N is 1, we are going to have 30 times 1, which will give us 30. And 30 is not in the option, so 1 cannot be the answer. If you assume that X is 2, we are going to have 30 times 2, which will give us 60, and it's not in the option, so it's not the answer. If you assume that this is 3, we have 30 times 3, which will give us 90. 90 is not in the option. If you assume that it's 4, we have 30 times 4, which will give us 120. 120 is not in the option. If we assume that it is 5, we have 30 times 5, which will give us 150, and 150 is not in the option. But if we assume that it's 6, we have 30 times 6, which will give us 180 as the molecular mass, and that is the answer. So we have this, because we can easily eliminate this. It's not there, it cannot be this, it cannot be this, but it's 180 when we assume that X is 6. So that is the answer to this. You can see the procedure. First of all, get what, using the empirical formula, what the mass will be, 30. Then anything that is the mass times N will give you the relative molecular mass, because we have always known that the empirical formula is the formula. Empirical formula times N is always equal to molecular formula. It's good you know this. So with that, with this formula, we can have this. So the empirical mass here is 30 times N, which we don't know, to give us the molecular formula. So we now assume that this N is 6. So that when we have 30 times 6, because N must be a positive whole number, it will give us 180, which is the molecular formula. Molecular mass, and that is this. Now, let's look at this problem, question number 42 for WAEC Chemistry 2018. Atoms are electrically neutral because they, A, do not conduct electricity, B, contain equal number of protons and electrons, C, are composed of neutrons and electrons, D, cannot be attracted by electromagnetic field. So what is the answer to this problem? Why are atoms electrically neutral?
Now, for us to understand this, we need to look at what atom is. For every atom, there is a nucleus, and this nucleus contains protons and neutrons. They contain protons and neutrons. Now, apart from this nucleus that contains protons and neutrons, we now have revolving around the nucleus the electrons. We now have revolving around the nucleus the electrons. So you can see that the smaller things inside an atom are the protons, the neutrons, and the electrons. So these ones that are in the shell are known as electrons. So this very place is known as the nucleus. It's known as the nucleus. And this nucleus is comprising of the protons. These protons are positively charged, and it also comprises of the neutron. These neutrons they are not charged, they are neutral. So that is for the nucleus. Then outside of the nucleus, we have what we call the electrons. These electrons are negatively charged. So for you to have an electrically neutral atom, there has to be the positive charges must be equal to the negative charges. So the ones that have positive charges are the protons, and the one with the negative charges from our diagram are the electrons. So for you to have neutrality, the proton number has to be equal to the electron number, because the neutron is neutral, so it doesn't affect the electrical neutrality of the atom. So the correct option now is that for it to be neutral, it must contain equal number of protons and electrons. The protons are positive and the electrons are negative, so they have to be of equal number for you to have electrically neutral atom. So because of that, B is the answer. Option A cannot be the answer. You cannot say that atoms do not conduct electricity, because they do. So B is the answer. And you cannot say that atoms cannot be attracted by electromagnetic field, because they do. And you cannot say that atoms are only composed of neutrons and electrons, because they also have protons. So the right answer to this question is that they contain equal number of protons and electrons to balance out the positive and the negative charges. Thank you. Yes, let's look at this question number 43 for Chemistry WAEC 2018. Common salt, NaCl, sodium chloride, is used in preserving foods. Which of the following properties could be used to determine its purity before use? Option A, solubility in water. B, melting point. C, relative density. D, crystalline nature. Now, whenever you're asked for the criteria for purity, if you want to confirm the purity of something, what you use are, number one, melting point, especially whenever you're talking about solids, or if the substance is in solid state. Another one is boiling point, when the substance is in liquid state. Now we also have what happens in the chromatogram. That's using chromatography. It has to have a single spot. If something that has to do with solute movement and color. So these are the three basic ways of this determining purity, or three basic ways to confirm purity. And that is what we are being asked here, how to determine the purity of this common salt, which is a solid. So the answer is simply melting point. That is what you can use. In some advanced way, you can also, as part of criteria for purity, you can also have relative density and crystalline nature of the substance. But these three are the basic ones. And you can clearly see that melting point is there. So that is why melting point is the answer to this problem. You can check it under separation techniques. That's where you can check this topic under separation techniques, under test for purity. You see all that I've said. Thank you. Now let's look at this problem number 44 for chemistry past question 2018. Which of the following electron configuration represents the transition element chromium with atomic number 24, Cr24? Is it A, 1s2, 2s2, 2p6, 3x2, 2p6, 4s2, 3d4? B, 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. C, 1x2, 2s2, 2p6, 3s2, 3d4, 4x1. D, 1s2, 2s2, 2p6, 3s2, 3p6, 4x1, 3d5. Now, for us to solve this, we need to take note of the atomic number of Cr, which we are given very clearly as 24. So anything we are adding up in our checking, let's check for the first one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Once we add all these exponents, it must equate 24 for it to be close to the answer. So let's add for the first one. We have 2 plus 2, this 2 plus this 2, plus 6, plus 2, plus 6, plus 2, plus 4. What do we get? 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 6 is 18, 18 plus 2 is 20, 20 plus 4 is 24. So we already have this. So we already have this 24 for chromium. But having that, is that enough to be the answer to this problem? Now, if we check for this other one, we have 2 plus 4, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 6, we also have 24. So can we say that this is now the answer? No, we cannot, because the electronic configuration has to be as after the s orbital, 1s orbital, you have to see the 2s orbital. Then the 2p orbital. After the 2p orbital, you see the 3s orbital. Then the 3p orbital. Then you see the 4s orbital. And that is not the way it is here. Here you have 1s, 2s, 2p, 3s, 3p, 3d. before the 3d orbital, as we have here, before this very 3d orbital that we have here, we are supposed to have 4s. It's missing, but it's here. So checking that here now also, before you get to 4d, 4s orbital must have up to 2 electrons, but here it's having only 1. So this is wrong. This is supposed to be 4s2, so that this one will be lesser, as we have here. And also here, after the 1s, you have 2s. After the 2s, you have 2p. After 2p, 3s. After 3s, there has to be 3p first. There has to be 3p and then 4s before the 3d. So this is also wrong. So this is the one that follows the rule that says that you must have 1s, and your 1s must have up to 2 electrons before you move to the next orbital, which is 2x. All the s must have 2 electrons. Then you now move to p, 2p, and p will be having maximum of 6. Then you move to 3x, x is always 2, that is the maximum, p is always 6. Then after that, you can move to 3p, that has maximum of 6 too. Then after that, you move to 4x, that has maximum of 2. And then 3d to fill out the remaining. In this case, we have 4. So that's how you move when you are calculating the electrons in electronic configuration. So A is the perfect answer for this. So you can see this under electronic configuration. Thank you. Let's look at this question number 45 for WAEC Chemistry 2018. The total number of an isotope of hydrogen is equal to its mass number because it A has a totally fixed valence, B has a high charge to mass ratio, C, this is actually C does not contain neutrons, D exhibits isotope. So what is the answer? To understand this, it is pertinent to know that the atomic number of an isotope, that is a given form of hydrogen, is equal to its mass number. Very, very important. Note that the atomic number is always equal to mass number. Why is this so? Because hydrogen does not contain neutrons. Hydrogen does not contain neutrons. Very, very important. I told us that when you have a nucleus, there is always the positive ones known as protons, and there are other ones that does not have charge, the neutral ones, and they are known as neutrons. So the combination of the number of protons and neutrons gives you what we call mass number. It gives you mass number. Whereas the number of protons alone is the atomic number. So proton plus neutron is what? Mass number. You understand? But since there is no neutron in hydrogen, that means the proton, the mass number is just the number of protons alone, which is also the atomic number. And that explains this question. So the answer is C, because it does not contain any neutron. That's why we have that very case. I hope this is very clear. Now the atomic number of an isotope of hydrogen the atomic number of an isotope. This is not total, sorry, this is the atomic. The atomic number is supposed to be atomic. The atomic number of an isotope of hydrogen is equal to the mass number because of what? You can see, as I've explained here, the atomic number is equal to the mass number because there is no neutron. It would have been different if there was neutron, because the neutron would have added to the number of protons to give a different mass number, but the atomic number remains constant. So that is the reason, because it does not contain neutrons. So the question, let me take it again. The atomic number of an isotope of hydrogen is equal to its number. If the isotope, if it's 2, once you're considering hydrogen, if the atomic number is 2, the mass number is supposed to be 2. If it is 1, the mass number is supposed to also be 1. If it is 3, atomic number, 3 mass number. That is how it is. Why is it equal? Because there is no neutron. No neutron. So you can now say that the what? Atomic number, which is the number of protons, is equal to the mass number, which should be the number of proton plus neutron. But because there is no neutron, number of proton here, this is number of proton, whereas this is number of proton plus neutron. But for hydrogen case, there is no neutron. So we have number of proton being equal to number of proton because there is no neutron. And that is C, does not contain neutrons. Let's look at this question number 46 for WAEC Chemistry 2018. The total number of shared pair of electrons in the compound below is, the compound here is methane with this structure. Option A, 5, B, 6, C, 10, D, 12. So how do we solve this? Now the compound we have is H going to C with double bond to another C. We have another H here, another H, and another H, all connected. And we all know that carbon has 4 electrons in the outermost shell. And this 4 is going to pair with other ones. So now we have 4 electrons at the outermost shell of this very carbon. Let's say it's this carbon. Then we have another carbon here with another 4 electrons. Now, you have how many hydrogen? You have 1, 2, 3, 4. You have 4 hydrogen. So, how are we going to have this bond completed? How are we going to have it completed? Now we are going to have this bonding with this to have this single bond. We're also going to have this bonding with this to have another bond, creating this double bond. Then these remaining atoms, hydrogen is going to come here, this one hydrogen, and bond with this. Another hydrogen is going to come with this one valence electron and also bond with this. Whereas these other 2 hydrogen, one is going to come here to bond with this. Then this other one is going to come here to bond with this. So how many electrons are involved in all this bonding? We have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, we have 10, we have 11, and we have 12. So we have 12 electrons being shared between them in this very action. So very, very importantly, with this sharing now, you have all of them to be completing their normal octet configuration. So with this sharing, this carbon will have the natural 4 it had before, 1, 2, 3, 4, but it's now pairing with this 5, with this one 6, with this one 7, with this one 8, making it complete. The same thing happens to this one. It's natural for 1, 2, 3, 4, but now pairing with this 5, getting this one 6, getting this one attached 7, getting this one attached 8, making it the normal 8. So that is how you go about this. So the right answer is 12. So to solve this, you must know that each carbon has how many valence electrons? 1, 2, 3, 4. But it needs 8 to complete. It has 4, but it needs 8 to be stable. So it's going to look for these electrons to make it stable. So it's getting 2 from the other carbon. If this is carbon, it will get 2 from this one. That's why we have double bond. So once it gets 2, it now has 6. So it's remaining other 2. So those other 2 it will get from the 2 hydrogen atom that is bonding with it. This other one will also get 2 from the hydrogen to complete it to 8 and make it stable. Thank you. Now, let's look at this question number 47 for WAEC Chemistry 2018. The bonding pair of electrons in a hydrogen chloride molecule is pulled towards the chlorine atom because A, chlorine, please, this is a mistake. There should be no extra O here. Chlorine has a larger atomic size. B, chlorine has a larger atomic mass. C, chlorine is more electronegative. D, there is no bonding orbitals within the chlorine atom. So, for us to understand this much better, please, there is no O here and there is no O here. So for us to understand this, I had earlier in one of the exam questions explained that every atom has what we call protons and neutrons. Now the protons, let's say these are the protons, they are positively charged. The neutrons are not charged, they don't have any charge. Now, revolving around these protons and neutrons are what we call the electrons. They are revolving around. These electrons are negatively charged. So there is always forces of attraction between this negative charge and the positive charge in the nucleus. So now there are some elements that are very, very electropositive or electronegative. So things like chlorine and fluorine, they are highly electronegative. And things like sodium and potassium, they are highly electropositive. So if you are having something that is highly electronegative, it's going to be attracting. Whenever there is bond with, say, another element, the electronegativity is going to ensure much attraction of these bonded electrons. So we have chlorine being more electronegative as the reason why the paired electrons, this electron that is paired, one from this very chlorine and one from what it is being bonded to, the electronegativity of this chlorine is going to ensure that these electrons are being attracted towards the chlorine side. So that's why we say that the bonding pair of electrons, this bonding pair in a hydrogen chloride, say this is hydrogen. You know, hydrogen has one electron. Say this is hydrogen. A hydrogen chloride molecule is pulled towards the chlorine atom. It's going to be pulled towards this because chlorine is very, very powerful, and because of its highly electronegative nature, it's going to ensure that it is being attracted towards the chlorine and not towards the hydrogen. And that is the reason why C is the answer to this problem, and not because it has larger atomic mass or atomic size, though it actually does do these two things, but that is not the reason for the attraction. The reason for the attraction is the high electronegativity of chlorine. Thank you. Now let's look at question number 48 for WAEC Chemistry 2018. The solubility of CO2 in water can be accounted for by A. Van der Waals forces, B. Ionic attraction, C. Dipole attraction, D. Covalent bonding. Now, to understand this, we need to know the various types of bonding that we have, and those are very importantly, we have ionic attraction and covalent, but we also have weak van der Waals forces, and we also have dipole attraction. So these four are actually bonding types. But whenever you hear ionic attraction, we're talking about when there is ionic bonding, when there is complete transfer of electron from one, let's say you have these and you're transferring this very electron to another one that has a deficit of say 1. So when you transfer this one down here, this one will not get completed. Once there is transfer, we talk about ionic. But when the two of them have to come together like this in order to make the bonding to be complete, we talk about covalent. So ionic works when we have 7 electrons here and we have say 1 here. So you need to transfer this one to here to make it 8 to be stable. We call it ionic. But when you have almost equal number, let's say you have 7 here and you have 7 here or something like that, that they have to come together to share bond, to share electron, we have covalent. But when there is weak attraction, let's say you have a compound, say this is already a compound, you're no longer talking about elements. In this case, you're talking about elements and elements, say sodium chloride. You know that sodium has 1 and chlorine has 7. So there is transfer of this one to this chlorine to make it stable. And this one will return to 8 to also be stable. So in that case, you have ionic, positive and negative. When there is bonding, covalent bonding, like in organic chemistry, we have covalent. But this one is ionic. But when there is something like a compound already like CO2 mixing with water, we have what we call van der Waals forces, very weak forces, van der Waals. So A is the answer, and that is why we pick A as to be the answer, because there is van der Waals forces that connects this compound CO2 and water, making it to be soluble. So what is responsible for this type of bonding is van der Waals forces, because we can easily see that there is no transfer of electron and there is no covalent bonding between the CO2 and the water. Thank you. Yes, let's look at this question number 49 for WAEC Chemistry 2018. Which of the following properties would not influence electrovalent bond formation? Option A, electronegativity. B, electron affinity. C, ionization potential. D, catalytic ability. So which of these properties would not influence electrovalent bond formation? Now, once you are supposed to have electrovalent bond formation, whenever you hear about electrovalent bond formation, just know that we are talking about ionic bonding. Know that we are talking about what? Ionic bonding. So what are the things that affect ionic bonding? Number one is what we call electronegativity. That is how positively powerful or negatively powerful a given element is. Very, very important. Where it is placed in the electrochemical series. Where the very element is placed in the electrochemical series is very, very important. That's electronegativity. Then number two is what we call electron affinity. This electron affinity is also dependent on the electronegativity. That's the ability to accept electron. The ability for one element to accept the electron of the other element in its outermost shell. So the ability to accept this, to get this single electron transferred to this one. So if this is chlorine having 7 in the outermost shell, and this is sodium having 1, the ability for this to attract this one to complete it to 8 is electron affinity. It also affects ionic bonding. Then number 3 thing that affects is the ionization potential. Ionization potential. That's the Is ability to receive in order to be charged negative, and this one ability to release electron, to be charged positive, to be ionized. Whenever you're talking about ionization, you're talking about conversion to something that has charge, ions, formation of ions. This ability to form ion. And if it can form ion easily, it can form electrovalent bonding easily. So these are the 3 things that affect them: electronegativity, electron affinity, and ionization. So that makes D the answer. Catalytic ability does not have anything to do with this electromagnetic. It does not have anything to do with electrovalent bonding or ionic bonding. So that is the answer to this problem. Now let's look at this question number 50 for WAEC Chemistry 2018. Particles in a solid exhibit A. Vibrational motion only, B. Vibrational and translational motion, C. Vibrational and random motion, D. Random and translational motion. So what should be the answer to this? Please take note, this is random motion. So what is supposed to be the answer? We know under properties of solids, we know that we have 3 states of matter. We have what we call the gaseous state, and we have the liquid state, then we have the solid. So in gaseous state they are dispersed, in liquid state they are compact to an extent, whereas in solid state they are fixed, and they can only make vibrational motion here